All right, friends, so we are going to dive into a little bit more work with solving for x. And we have done, you guys did some where you were there was only one step to solve for x, right? So you were used to seeing something like this, x divided by 10 is the same as 70, or you might have seen something that looked like this, 3x is the same as 30, but we are now adding some extra steps. Okay, so this is solving for x when there is more than one step that you have to do. Now, when we're looking at this, the same exact rules apply. My main goal is to get x by itself, right? Now, when we're trying to get x by itself, what we are used to seeing is just one thing with x, right? And so I'm used to seeing 3x equals 30, but I'm not used to seeing this extra 15. So my first goal, if I have two pieces now to my x side of the equation, is I'm trying to get x as close as possible by itself, which means I really would like this 3x to be alone so that I can just get x alone. If I want 3x to be alone, that means I have to get rid of this negative 15, right? And we know from our last lesson that if something is being subtracted on one side, the way to get rid of it is to add it so that they cancel each other out, right? They're called the inverse operations. So if I want to get 3x alone so that I can get x alone, I need this 15 to just be gone. So I'm going to add 15 to my negative 15. And if I do it to my left side, I have to do it to my right side. So I'm also going to add 15 over here. That will get me to 3x equals 45. Now this looks more like what we're used to. Okay, 3 times the number will get me to 45. If x is being multiplied by 3 over here, and I want to get rid of that 3, I'm going to use my inverse operation. The opposite or the inverse of multiplication is division. So I want that 3 to be gone. I'm going to divide 3 by 3. It's going to cancel those 3's out. If I do it to my left side, I have to do it to my right side. I'm going to divide by 3. And x is the same as 45 divided by 3. And I can simplify that even further. And I can say that x is the same as 15. Now I always want to go back and check. So I'm going to put 15 in for x. 3 times 15. And remember, if I just put it in parentheses next to my 3, I don't even have to use a multiplication sign. This already tells me I'm multiplying. So 3 times 15 minus 15 is going to equal 30. 3 times 15 is 45. 45 minus 15, that does equal 30. 30 equals 30. Checks out. Let's try another one. All right, here is our next problem. 30 plus x divided by 10 is the same as 70. The whole goal is to get x alone on one side. And this 30 is extra right now. It'd be really nice if it was just x divided by 10 because I'd only have to do one thing. So let's get rid of the extra information that is keeping us from just having x divided by 10. So I'm going to get rid of this 30 by subtracting it because right now it's positive and I need the opposite. So this will these two will cancel each other out to make 0. And now I have x divided by 10 is the same as 40. All right, when I have a division on one side, when I'm dividing by 10, and I need to get x alone, I need to do my opposite. I need to multiply. Now, I'm not going to multiply by x because that wouldn't get me x alone. That would keep 10, I'd still be dividing by 10. And I need to get 10 away. So I'm going to multiply by 10. Okay, if I do it to this side, I have to do it to this side. 10 divided by 10, that's going to cancel each other out to make 1. And we're going to say x is the same as 40 times 10. X is the same as 400. And let's plug it back in to see if that actually is the case. So 30 plus 400 divided by 10 equals 70. I'm going to do 30 plus 400 divided by 10 is 40. 70. 70 plus 70. Oh, 70 equals 70. Checks out. All right, you are going to click on the link and you are going to mess with trying to solve for x when there is more than one step involved.